Hello Z students, RAHUL JALAN this side. Welcome to my new video, and in this video lecture we have to deal the problems based upon osmotic pressure present in sticker number 8. Sticker 8 is already provided to you through WhatsApp group. Probably all of you deal with all the questions of this sticker so that you may have many of the doubts in this particular sticker. After watching the whole video lecture, you can clear each and every doubt you have present in this particular sticker. First of all, improvise the quality of this video from the button right at the top of your mobile screen. Before starting to solve these problems of this particular sticker, first we revise the basics and formulas present in osmotic pressure. Let me start. To know the details of this topic, you can click the I button right present here and understand all the terms in detailed manner of osmotic pressure. Now, first we understand what is osmotic pressure. Osmotic pressure can be explained in two different manners. In first manner, osmotic pressure can be defined as the excess hydrostatic pressure developed in solution side to just stop the process of osmosis is called osmotic pressure. And in second manner, osmotic pressure can be explained as the additional pressure exerted on the piston of solution side to just stop or prevent the process of osmosis is called osmotic pressure. That is explained in two different manner by two different figures in related lecture. Okay student, now we move further. After understanding osmotic pressure, now the first question arises around us is that how can we determine osmotic pressure of a given solution? Really, in laboratory, osmotic pressure of any solution can be determined by Berkeley-Hartley method, that is some other kind of thing, but here we have to define the mathematical equation by which we can determine osmotic pressure of any solution. Okay student, now we proceed further. From ideal gas equation, we know that PV is equals to nRT. At the place of P means pressure, if we put osmotic pressure pi, and at the place of V, if we put V solution means volume of solution, and at the place of number of mole, we put number of moles of solute of the solution, and at the place of R and T, we put as it is. Okay, then what will be the value of osmotic pressure? Means pi will becomes equals to number of moles of V by volume of solution into RT. What will be the value of number of moles of solute divided by volume of solution? This is the another concentration terms used in this equation. It can be written as C, and what is C? C is molarity of solution. Okay, C is molarity of solution, means this concentration terms is used in molarity. Here in this equation, pi is osmotic pressure that can be determined after multiplying C means concentration of solution in molarity of solution into gas constant. The value of gas constant is written on the basis of unit of pi. If the value of osmotic pressure is written in atm, then the value of R is used as 0.0821 atm liter per mole per Kelvin, and if the value of osmotic pressure is in bar, then the value of R is written as 0.083 bar per mole, bar liter per mole per Kelvin. Okay student, and here T is absolute temperature. How we can determine the molar mass of unknown solute on the basis of osmotic pressure method? Okay, if we have given some unknown solute and we have to determine the molar mass of this unknown solute, then we can do it by this formula that can be developed from here. We know that pi is equals to CRT. What will be the value of C? C is number of moles of solute divided by volume of solution into RT. Now, what will be the value of number of moles of solute? That is mass of solute divided by molar mass of solute divided by volume of solution into RT. What we have required? We require molar mass of unknown solute. Then molar mass of unknown solute is equals to what will be the value of molar mass of a known solute? This will becomes equals to mass of solute into R into T divided by volume of solution or into pi. So from this particular formula you have to learn this formula, and you must have to remember this formula also. Molar mass of unknown solute is equals to mass of solute into R into T divided by volume of solution into pi. So all the problems based upon osmotic pressure in any level of examination can be solved by knowing these two formulas only. Pi is equals to CRT and molar mass of unknown solute is equals to mass of solute into R into T divided by volume of solution into pi. Since this sticker consists lot of problems, that's why we do all the problems in summative fast manner. Okay students, let me start. As in question number 1, at 300 Kelvin, 36 gram of glucose present per liter in its solution has a osmotic pressure of 4.98 bar. If the osmotic pressure of solution is 1.52 bar at the same temperature, what would be the concentration? First of all, we write all the given values. The first given value is temperature, that is 300 Kelvin, and mass of solute, that is glucose, which is 36 gram. Okay student, what will be the molar mass of glucose? That is 180 gram. So from these two terms we can determine number of moles of solute, that is 36, mass of solute divided by molar mass of solute, and it will be 0.2 mole. Okay student, the next term given in the question is that 36 gram of glucose per liter of solution means what? Volume of solution is 1 liter. So that concentration of solution is number of moles divided by volume of solution. What will be the number of moles of solute? That is 0.2 divided by 1 means 0.2 m. Okay student, and it is also given that its osmotic pressure is 4.98 bar. If the osmotic pressure of solution is 1.52 bar at the same temperature, what will be its concentration? It is given in the question that if the osmotic pressure is 1.52 bar of the same solution at same temperature, what will be its concentration? Then what will be its concentration? From the data given in above case, first we determine the value of R, means gas constant, and then the gas constant is put up in this given data, and from here we can calculate the concentration of next solution. Okay, from this data we can calculate the value of R. We know that pi is equals to CRT, so that what will be the value of R? It will be equals to pi divided by CT. What will be the value of pi given in the question in first case? That is 4.98 divided by C means what? 0.2, and temperature is given in this question is 300. This is the value of R. Now in second case, we put the same value and calculate the value of C. We know that pi is equals to CRT. Then what will be the value of concentration? That is equals to pi by RT. What will be the value of pi given in question? That is 1.52 in second case divided by R into T. What will be the value of R? That is 4.92 divided by 0.2 into 300. And what will be the temperature in question? It is given that same temperature, means in first case it is written 300 Kelvin. That's why we use the same temperature here also. After solving this mathematical equation, we find the concentration in terms of molarity. Okay students, according to question number 2, average osmotic pressure of human blood is 7.4 atm at 27 degrees Celsius. It must have to be remembered that average osmotic pressure of human blood is 7.4 atm. Calculate total concentration of various solutes. Okay, assuming this concentration to be molarity, calculate the freezing point of blood. Okay, in this question number 2, it is given that average osmotic pressure of human blood is 7.4 atm. What will we put the value of R here? As according to atm, we put the value of R is 0.0821 atm liter per mole per Kelvin. Okay, and what is the temperature given in this question? That is 27 degrees Celsius, means what? 300 Kelvin. Calculate total concentration of various solutes. What will be the concentration? Since we know that pi is equals to CRT, so that C is equals to pi divided by RT. What is the value of pi? It is written right from here, 7.4. What is the value of R? 0.0821. What is the value of T? That is 300. And this concentration is actually in mole per liter, means molarity. But according to question, let me assume that molarity of solution is same as that of the concentration obtained from this data, that is equals to 7.4 by 0.0821 into 300, because it is given in this question, mole per kilogram. And it is also given that Kf for blood water is 1.86 Kelvin kilogram per mole, and from this data we have to calculate the freezing point of blood. Since we know that del Tf means depression in freezing point is equals to Kf into m. What is the value of Kf? That is 1.86, and what is the value of molarity? That is 7.4 by 0.0821 into 300. From this data we can calculate depression in freezing point, so that freezing point of blood is, what is freezing point of pure water? That is 0 degree Celsius minus del Tf, The value of del Tf is written right from here, so we obtain minus 1.86 into 7.4 by 0.0821 into 300 degrees Celsius. This is the freezing point of blood. Now we proceed towards the next question, and according to question number 3, calculate the osmotic pressure of a solution obtained by mixing 100 milliliter of 1.5% weight by volume solution of urea and 100 centimeter cube of 1.8% solution of glucose at 26 degrees Celsius. Okay. As in the question, it is given that there is two solutions. Calculate the osmotic pressure solution by mixing. The first solution is 100 milliliter and 1.5%. This is volume of solution, and it is 1.5% weight by volume. Means what? Mass of solute is 1.5%, matlab 1.5 gram. And since this solution is of urea, so that molar mass of solute is 60 grams, so number of moles of solute is equals to 1.5 by 60 mole. Okay student. Similarly, for the second solution, that is adder, is also 100 milliliter. Means what? Volume of solution is how much? 100 milliliter. Centimeter cube and milliliter are same terms, and it is also given that it is 1.8% by mass by volume. So mass of solute is 1.8 gram in 100 milliliter of solution. Molar mass of solute, because the second solute is glucose, that's why it is 180 grams, so that number of moles of solute is 1.8 by 180 mole. Okay students, when these two solutions are mixed together, then volume of resulting solution will becomes 200 milliliter, means what? 0.2 liter, and number of moles of solute, since all the solutes are considered as same, that's why number of moles of solute is equals to 1.5 by 60 plus 1.8 by 180 mole. Okay student, so that concentration of resulting solution will becomes number of moles of solute, that is 1.5 by 60 plus 1.8 by 180, this is number of moles of solute, divided by volume of solution, that is this much amount of mole per liter. And in the question it is also given that temperature is 20 degrees Celsius. Means what? Temperature is 20 degrees Celsius, means what? 293 Kelvin, and R should be taken as 0.82 liter atm liter per mole per Kelvin. So that from here we can calculate the value of osmotic pressure of this solution as pi is equals to CRT. What will be the value of C? That is 1.5 by 60 plus 1.8 by 180 divided by volume of solution, that is 0.2 liter into R, 0.082 into temperature, that is 293. After calculating this mathematical equation, we find the value of osmotic pressure in atm, something atm. That one is the answer. As according to question number 4, calculate freezing point of an aqueous solution of non-electrolyte having osmotic pressure of 2 bar at 300 Kelvin. Kf is given 1.86 Kelvin kilogram per mole. R is given 0.083 liter bar per Kelvin per mole, and assume molality and molarity to be same. Okay, it is also the second type of question, and according to this question it is given that if osmotic pressure of 2 bar, means osmotic pressure is given in this question as 2 bar, and R is given in this question 0.083 bar liter per mole per Kelvin. Okay student, and temperature is given in this question as 300 Kelvin. From this data we can calculate the concentration of solution, that is equals to pi by RT. Since pi is equals to CRT, from this equation we can find the value of concentration of solution, that is equals to pi by RT. What will be the value of pi? That is 2 by R, 0.083 into temperature, how much? 300. This is mole per liter actually. Okay, but in the question it is given that molality of solution M is equals to molarity of solution, that is concentration determined from right here. So we put the value of molality as 2 by 0.083 into 300 mole per kilogram, because in this question it has to be assumed. So in question it is also given that Kf of solvent is 1.86 Kelvin kilogram per mole, and we have to determine the freezing point of aqueous solution. So first we determine del Tf, that is equals to Kf into M. What will be the value of Kf? That is 1.86 into molality, and the value of molality is 2 by 0.083 into 300. Okay student, this is del Tf. So what will be the freezing point of solution? That is 0 minus del Tf, 0 minus del Tf, because 0 is the freezing point of pure water. So this much amount of depression, after this much amount of depression, the freezing point will become equals to minus of del Tf. Whatever be its value, this much amount degree Celsius is freezing point of given solution. Now we move towards question number 5. According to question number 5, 100 milligram of a protein, that means unknown solute, is dissolved in enough water to make 10 milliliter of solution. If this solution has osmotic pressure of 13.3 millimeter of Hg at 25 degrees Celsius, what is the molar mass of protein? Very easy question. In this question it is given 100 milligram of protein, means in question mass of solute is given 100 milligram, but we have to convert this term in gram, so that this one will become 0.1 gram. And it is also given in this question that the volume of solution is 10 milliliter, means 0.01 liter. Okay student, if this solution has osmotic pressure, in this question it is given that osmotic pressure of solution is 13.3 millimeter of Hg, we can convert this in atm, that is equals to 13.3 by 760 atm. Okay student, at 25 degrees Celsius, what is the temperature of this solution? That is 25 degrees Celsius, that is 298 Kelvin. What is the molar mass of protein? From here we have to determine molar mass of protein. Molar mass of protein means determination of molar mass of unknown solute. Have formula mass of solute into R into T divided by volume of solution into pi. So after putting all these terms right from here, we can easily determine molar mass of solute as mass of solute 0.1, R 0.0821 T 298 divided by volume of solution as 0.01, and the value of pi is given in question as 13.3 divided by 760. After calculating or solving this mathematical equation, we find the molar mass of solute in gram. According to question number 6, pickles are made by soaking cucumbers in salt solution. Out of salt solution or liquid in cucumber which has higher osmotic pressure, justify. It is given in question that out of liquid in cucumber, this is the cell sap of cucumber cell, that is liquid in cucumber, and this is outer solution. This is outer solution of salt. This is outer solution of salt. Okay, student. As we already studied in application of osmotic pressure in previous lecture, that how we made up pickles, mangoes, pickles, etc., where after addition of salt, the water, excess water or moisture present inside the cell is removed out due to osmosis. Why osmosis occur? Because the concentration of outer solution, if here we assume that concentration of outer solution as C1 and concentration of solution inside the cucumber as C2, then here C1 is greater than C2, so that the vapor pressure of the solution inside the cucumber is greater than the solution the vapor pressure of salt solution, so that osmosis, the process of osmosis occur from inside to outside. That's why shrinkage of cells of cucumber occur. And but here in the question it have to be asked that which one have higher osmotic pressure. We know that since osmotic pressure is directly proportional to concentration of solution, and since the osmotic pressure of liquid inside the cucumber is lower, that's why the osmotic pressure of outer solution, means salt solution, is greater than osmotic pressure of cucumber. Okay, this is the answer. This is the osmotic pressure of cucumber and this is osmotic pressure of salt solution. Okay, student, probably you all understand. According to question number 7, calculate the osmotic pressure of a solution containing 1 gram of glucose per 100 milliliter of the solution at 25 degrees Celsius in Newton per meter square. Molecular mass of glucose is 180. Very easy question. In this question it have to be asked that what will be the osmotic pressure of solution containing 1 gram of glucose. Mass of glucose is 1 gram. We know that molar mass of glucose is 180 gram in per 100 milliliter solution, means volume of solution is 100 milliliter, means 0.1 liter. From these two data we can calculate number of moles of glucose as 1 by 180 mole, mass of solute divided by molar mass of solute, so that at temperature that is given in question as 25 degrees Celsius, means what, 298 Kelvin, we can determine osmotic pressure. Since osmotic pressure is equals to CRT, so the value of C is number of moles of solute, that is 1 by 180 divided by volume of solution, that is 0.1. What will be the value of R? Here we put the value of R as 0.0821 into temperature, that is 298 Kelvin. But this term is obtained in terms of ATM. Here osmotic pressure is obtained in unit ATM, but in question it have to be asked that we have to calculate the osmotic pressure in Newton per meter square. So multiply all this term, 1 by 180 divided by 0.1 into 0.08 21 into 298 by 1.013 into 10 to the power 5 to obtain osmotic pressure in Newton per meter square, because all of us know that 1 atm is equals to 1.013 into 10 to the power 5 Newton per meter square. That is also called Pascal. Okay, student.